I'm going to give you a talk with the title of I Spy with My Little Eye, and I hope by the end of this you'll understand a bit why I became an eye doctor. There's lots of reasons, not least of them is that I'm rather squeamish, and when Tim's talking about poo transplants and things, I don't want to know, thank you very much. Also, your eyes are closed at night, so I get a good night's sleep as a doctor, that's marvellous. But the main reason I became an ophthalmologist is that the eye is truly fascinating. So many diseases, so many aspects of our lives are represented in our eyes. And I hope I'm going to show you how our eyes reflect our past, our present, and our future in the next few minutes. There are so many quotes we know about eyes. As you've heard earlier today, the eyes are the window to the soul. And many people think that we're actually superhuman as ophthalmologists. And I had one 58-year-old lady who came to see me. She hadn't had her eyes tested for over 20 years. And I said, oh, why not? She said, I did something terrible in my past, and you might see it. What do you answer to that? I had to say, we may be clever, but not that clever. So, of course, the eye is a camera, and it's the most amazing camera. We can see in the almost complete dark. We can read the newspaper on a bright, sunny day. That's a huge range of contrast that really cameras, even today, haven't picked up the sensitivity. As you heard earlier, our retina can pick up movement in our peripheral vision in the near darkness with amazing ability. And there's a huge amount of processing goes on in the retina. And as you see from the diagram behind me, light is focused through the cornea, the window of the eye, and then the lens behind it here and onto the retina at the back of the eye. But what do we see when we look into the eye? Well, one of the things we look at is the lens of the eye, which is just behind the pupil. And here we see the lens of someone who has no cataract in their eye. And cataract is very common as we get older. Indeed, it's the most common operation performed in the Western world, and something like over 300,000 cataract operations in the UK. Why do we get cataract? Well, there are many reasons. But here we can see on this graphic someone's lens going cloudy as they develop a cataract. And what has been shown is that the amount of cataract we have is in some way an indicator of mortality. People who get cataract early are more likely to die early. So the lens gives us a measure of how well we can resist those effects of aging that Claire was just talking about. And the reason for that is that light streams through our eye all our lives and oxidizes the proteins that make up the clear lens. And our ability to resist this, what's called oxidative stress, is manifest in the lens. And if you can resist it in the lens of your eye, you can resist it in the rest of your body and therefore resist some of the stresses of growing old. So cataract can, to some degree, tell us how well we are aging. Also, when we look at the retina at the back of the eye, we can see the arteries and the veins. Now, the pattern of arteries and veins on your retina is completely unique to you. So it's certainly a viable alternative rather than, for example, iris recognition in the airports these days. You could actually recognize your retina looking at the pattern of the retinal vessels. And the retinal arteries and veins are the only blood vessels in our body that we can actually directly visualize. And they can tell us information about the state of our general cardiovascular health as well. So we can measure the diameter of the arteries and the veins, and that can tell us, for example, whether someone has an increased likelihood of developing a stroke in the future, developing high blood pressure, developing heart attacks. So again, the eye is pretty amazing. We can actually see the circulation and see how healthy or otherwise it is. You also saw in that last photograph, the central part of the photograph is the optic nerve, which takes the pictures through to the brain. And in fact, it's the only part of the brain we can directly see. And nowadays, we have scans called OCT scans, which are, in effect, living three-dimensional cuts of the retina where we can look at the retinal layers. And we can measure something called the retinal nerve fiber layer. And that represents the health of our nerve cells and is related to the density of brain cells in our brain. And as you saw from Claire's MRI earlier, people who are losing brain cells and therefore at risk of developing dementia they have thinner retinal nerve fiber layers. So this may be a marker that we can use in terms of trying to test new strategies. And certainly there's some interesting work going on looking at the effects of exercise on your retinal nerve fiber layer as a marker of that exercise protection of aging. So it's pretty incredible, isn't it? The eye can tell us an awful lot about a person, not just simply relating to the fact that it does focusing and sees. Well, they say two things you can't avoid in your life are death and taxes. And I'm going to suggest a third thing you can't avoid, and that's wearing spectacles. This is an old figure from the 1970s, but it shows illustrates the point that during the teens and the 20s, the amount of people wearing glasses goes up, and that's mainly due to myopia or short sight. And then there's a little lull, and then from the 40s onwards, middle age strikes, and people have to wear reading glasses, such that by 60, something like 95% of the population need to wear glasses. So clearly our eye's fantastic, but it's not always good at maintaining our focus through our lives. But what does the size of the eye tell us? My little eye is the title of this talk. Well, when we're born, our eye's pretty small, as the rest of us is, and at a week of age, the eye is about 17 millimeters in length. And the eye grows fairly rapidly, but when we're born, we're all long-sighted, and that is that the rays of light are focused behind the retina because the eye is still very short. Now, we can overcome that long sight by altering the focus of the lens of our eye. So children in particular are very good at overcoming long sight, so they can bring the focus onto the retina at the back of the eye. And the eye grows fairly rapidly over the first few years of life, and the axial length is 18 millimeters at about 3 months of age, and it is growing fairly steadily during our infancy. And by the age of 2 years old, it's about 21 millimeters in length, so still less than an inch. At that stage, the cornea, the window of the eye, which actually does 3/4 of the focusing of our eye, is sort of pretty much fully grown, which is why the eye is relatively much bigger in our bodies than the rest of our bodies. So when you look at cartoons of children and baby animals, Bambi and so on, they've always got enormous eyes in relation to their body size, because that's actually true about humans as well. And we continue to grow, and 3 and 5. And by late childhood, early adolescence, our eye is now mature, and the eye stops growing. We've actually reached a point called emmetropia, at which rays of light from the distance are focused directly onto the retina by the lens. Now, this is an active process that's controlled by the eye itself. You can cut, in animal studies, you can cut the optic nerve to the brain, and the eye will still grow until it reaches focus and then stop growing. And the signal to stop in animals is very powerful. But in humans, and in a large proportion of this audience I see before me, some of us, the eye continues to grow, and indeed in over 1/3 of the population become myopic. Our eyes grow too long, and in effect we have eyes that have grown backwards too long. It's almost like an egg on its side rather than a nice round football, and we become myopic. And the question is, why is this? No other animal has myopia naturally. It's only humans who develop myopia. Well, we've already heard reference today to nature versus nurture. And as you've heard, twin studies, before I move on to that, you can see that the light is focused in front of the retina now because our eyeballs are too long, and unfortunately we can't overcome that. We have to wear spectacles, contact lenses, or have laser surgery to correct our short sight. So twin studies, as you've heard today, have been used to try and work out how much of this variation is due to genetic factors and how much of it is due to environmental factors, the nature versus nurture, or as we should say after Julian's talk, the nature and nurture discussion. Well, we've measured the degree of short and long sight in over 3,000 pairs of twins at King's College London. And the graph on the right shows the results. If we plot the degree of short and long sight of twin 1 against twin 2, on the right-hand side here we see the identical twins, and they're really very similar. If one is short-sighted, the other twin is very likely to be short-sighted, and indeed a very similar level of short sight as well. But the non-identical twins on the left-hand side of the graph, you can see there's much more scatter. They're still related, but much more scatter around it. And when we do the maths, we suggest that the degree of heritability, that's the amount of variation in our refractive error in this country, is something like 80%. So a very highly heritable trait. And indeed, we've just published a GWAS. We heard about the genome-wide association scans earlier from David Collier, and we've just published a study of over 45,000 people from 27 studies around the world, and we've identified 26 genes now that are related to myopia, and hopefully will give us some idea about the mechanisms that cause short sight, and indeed develop future treatments to prevent myopia developing. But we're a long way away from any effective treatment. So is it all your genes? Well, of course, as you've been hearing today, it's certainly not. There are many lines of evidence as to why that we're not all myopic, why it's not all genetic, and certainly the amount varies between populations. So we see quite a variety of prevalences. It's much more common, for example, in the Far East than it is in Europe. And although there are some genetic differences between populations, on the whole, we're all pretty similar genetically as humans. Indeed, there's been a massive increase in the amount of myopia. In countries like Taiwan, 95% of undergraduates are myopic. In Singapore, over 90% of 18-year-olds are myopic if they're Chinese. Indeed, even in the Western countries, the prevalence of myopia is increasing really quite dramatically. And these changes have occurred within a generation, which means it's not due to our genes. Our genes don't change, they evolve over many, many, many generations. So what are the risk factors for being short-sighted? Well, one of the major risk factors is education, and that's why many of us are short-sighted in KCL TEDx, because we're over-educated. The amount of myopia correlates with the number of years you've spent in education, be it school, university, postgraduate study. Also, urbanization. So countries like Japan and Taiwan have huge differences in the prevalence of myopia between children in urban areas and children in rural areas. And while education is in part tied up with that, it's certainly not all. We know that we myopes are on average a little more intelligent than the non-myopes, and there's been this theory of big eye and big brain. Maybe they somehow go together. But the most recent risk factor that's been looked at is outdoor activity, that if you spend time outdoors as a child, you're less likely to become myopic. And the most interesting data for me comes from a study looking at 6-year-old Chinese children. In Sydney, only 3 out of 100 Chinese children aged 6 are short-sighted. In Singapore, 30 out of 100 Chinese children are already short-sighted by the age of 6. And when they looked at the differences between the two groups of Chinese children, the only difference they could find is that Sydney children spend on average 2 hours a day outdoors. Singapore children spend less than half an hour each day outdoors. So clearly, at the moment, our level of evidence is if you want to avoid your children becoming short-sighted, send them out to play, even if it's February in England. And that may be because the light levels, even on a grey English day, are much better, much stronger than indoor light levels. And it's possibly also looking into the wide blue yonder, as opposed to the rather red atmosphere of artificial light and indoor activity. So what's incredible is the size of your eye reflects not only your genetic heritage and where you come from, but also the environment that you've been exposed to as a child. And so the old wives' tale that you shouldn't read too much in the dark with poor light is probably true, in fact, as ever. So I hope I've managed to convince you that the eye is a very interesting, albeit very small part of our body, and reflects so much about who we are, where we've been, and where we're going. I wanted to end with a quote, and there are so many wonderful quotes, and Helen Keller, the most famous blind person, who said that sight must be one of the most delightful of the senses, and drink to me only with thine eyes, wonderful poem. But instead, because it's nearly the end of the day, and because you must always remember also that your eyes may deceive you, maybe we should conclude with this quote, that beauty is in the eye of the beer holder. I hope you can join us for a drink afterwards. Thank you very much.